Iodometry consists of the following two processes. First, an oxidizing agent to be determined is reduced by an excess amount of iodide ion to yield iodine. Next, the amount of the oxidizing agent is calculated based on the titration value of the iodine. The determination of sodium hypochlorite in household bleach will be explained. Take the prescribed amount of the reducing agent, potassium iodide, in a beaker. Dissolve this completely in distilled water. Add the diluted bleach to this solution using a volumetric pipette. Next, add the prescribed amount of hydrochloric acid. Mix well and then allow to stand for more than 5 minutes. Hydrogen ion as well as iodide ion is necessary for this reaction. If hydrogen ion is insufficient, the hypochlorite ion cannot be completely reduced. Titrate the reaction solution with a solution of sodium thiosulfate whose concentration has been determined. When the reaction solution turns light yellow, add a few drops of starch solution to increase the sensitivity of titration. The color of the reaction solution turns deep due to the reaction of iodine-starch. At this point, the titration reaches almost the end point. Hereafter, you should add the titrant more carefully. When the solution turns colorless, it is the end point. Let us join the two reactions in iodometry to one equation. As seen from this equation, 2 moles of thiosulfate are necessary for 1 mole of hypochlorite to be reduced. Therefore, the concentration of sodium hypochlorite is calculated by this equation having a multiplying factor 2. Let's compare the color changes around the endpoints of iodometry and neutralization titration. It can be seen that the reaction of iodometry is a bit slow. Thus, you may land up adding excess of titrant of iodometry if you add it at the same rate as in neutralization titration. Pause for a while before you add the next drop.